All right, so for homework, you had to evaluate some logarithms. Now, if you have a fancy calculator, or if you're using an online program, then you can just punch these in, and it'll give you an answer. But you know, that's one way to do it. But that's not what I was looking for. There's, we'll have to do that in the near future. Excuse me, and I'll tell you how to do that. But for these, I wanted you to kind of think about it. Right. So part of the process here was rewriting the logarithms as exponents and using that to solve. So the first one we had log base 3 of 27 equals x. So remember, as an exponential function, to rewrite this, it's telling us that our base is 3, and we want to know what power do we raise that 3 to get us 27. Now, once you have it at this point, you can kind of either use just, logical thinking, or you can use the method that we used when we were dealing with exponential functions, and we can break down the 27. Right? 27 is 3 to the third, so here our x has to be 3. Right? Or again, you think to yourself, 3 to what power gives us 27? And, if you're able to do that, you get x equals 3 for that one. All right, so your first solution is 3. For the second one, log base 12 of 12. Now, this was one of our properties that I went over at the end of class yesterday. Anytime our base and our input are the same, that answer is always going to be 1. Right? So you didn't even really have to think much there. That answer is 1. If you wanted to set it up like we did before, okay, you plug in the x over there on the right side. You have to ask yourself, 12 raised to what power is 12? And there's only one answer for that, and that is 1. Okay. The third problem was also one of our properties. Okay, anytime we plug in 1 to our logarithmic function, no matter what our base is, the answer has to be 0. Because anything to the 0 power is always 1. Okay, and again, that's one of the properties that we went over towards the end of class yesterday. All right, the last two were thinkers. Okay, they involved a little outside of the box, maybe not so straightforward. So I'll do it this way. All right, so we have the fourth one, we had log base 25 of 5. So you got to think to yourself, what do I raise 25 to get 5? So again, if your answer or if your result is smaller than your base, but it is not a fraction, then your exponent will be a fraction, right? So here, right, what do we have to do to get 25 to look like 5? Right, we talked about this yesterday. Well, we have to take the square root. Taking the square root gives us an exponent of 1/2. If you did this algebraically, right, 25, I can rewrite it as 5 squared. So here, 25x would become 5 to the 2x, because I changed 25 to 5 squared. Here I have an exponent of 1. So if I solve 2x equals 1, I get x equals 1/2. And for our last one, okay, here, if similar to this one, our result is smaller than our base, but now we have a fraction. Okay, if we have a fraction here, more than likely our answer, our exponent, will be a negative number. Okay, so again, I'm going to rewrite this a few times. So I have 2 to the x on the left side. 1 over 8 I can rewrite as 8 to the negative first. And then to get a similar base, right, 8 is 2/3, 2 to the third, so that becomes 2 to the negative 3. So for our last one, we get x equals negative 3. Or log base 2 of 1 over 8, excuse me, is negative 3. All right, any questions about the assignment? All right, so today we're going to talk about those last two properties that we talked about. Where did I put them? There we go. All right, so today we're going to talk about properties 3 and 4. Property 3, like our exponential one, is pretty straightforward, so I don't want to spend too much time on that. And then with property 4, we're going to learn how to actually solve exponential problems that aren't straightforward. All right, so let's jump into some examples. All right, so concerning property 3, if we have two logarithms that are set equal to each other and our bases are the same, then essentially we can forget about the logarithm part and we can focus on what's in the parentheses, right? So just like when we were talking about exponents, right? If I had something that looked like this, I would just set my exponents equal to each other. Okay. In a second, I'm going to show you why we can actually do that mathematically. But for now, right here, I have a log base 6. Here, I have a log base 6. So I can forget about that. And I could just set 2x plus 1 equals 3x. And then I would go through my normal algebra procedures to solve. All right, so I would subtract 2x from both sides, and I'd end up with x equals 1. And you can always double check, right? If you plug in 1 here, 2 plus 1 is 3. 3 times 1 is 3. So log base 6 of 3 equals log base 6 of 3. All right. Let's do one more. So I have log of x squared minus 6 equals log of 10. So again, I'm going to keep reminding you. For now, it doesn't really matter because these are the same. But if you don't see a base, it's always going to be base 10, right? We went over that yesterday. That's called our common logarithm, log base 10. But for now, it doesn't matter because they're the same, right? So we have x squared minus 6 equals 10. Now, there's two ways we can do this. I can subtract 10 from both sides and then factor. Or I can do this algebraically straight. I can add 6 to both sides. So I get x squared equals 16. And then when I take the square root, don't forget, all right, we're not in geometry anymore. Anytime we take the square root, I have to add plus or minus. Okay, and the square root of 16 is 4. So I have two answers here, plus or minus 4. I do want to say, be careful though. Go back and check your answers. One of the first things that we learned about the logarithms is that the domain is all positive numbers. So you might get, going back to our algebra, an extraneous solution, right? So you might get a solution that when you go back and plug it in, it doesn't work. Luckily for both of these, if I plug in positive 4, that gives me a positive 10. If I plug in negative 4, that also gives me a positive 10. Okay, so that works out. But it may happen where one of the answers is not an actual solution, all right, but it is extraneous. All right. Any questions about doing those basic ones like that? And I think that's pretty straightforward. Like I said, I don't want to spend too much time on that. Okay, so we're going to tie everything together now with this fourth property here. So first, let's just take a look at a simplification problem. We'll do 2. All right, so I want you to get used to seeing these as inverse operations. Okay, anytime we have an exponential and a logarithm that have the same base, those are opposite operations. Okay, those will cancel each other out. It's like if I wrote 2x divided by 2. Right away, you can cancel out the times 2 and divided by 2, and you're just left with x. So here, to simplify, if I have 20 raised to the power of log base 20 of 3, well, this is a base of 20. This is a base of 20. So the only thing that remains after we eliminate things is just the 3. Okay. Similar setup is if it's reversed. Log base 6 of 6 to the 4th power. Well, this is a base of 6. This is a base of 6. So the only thing we have left over is the 4. Okay, and technically, that's how we solve these problems up here. So, how do I want to do this? All right, so yeah, let's revisit this one. So, formally, okay, if you want to be super thorough, to solve something like this, right, it's not proper for me to just say, all right, let's forget the log base 6 and let's just look at what's in the parentheses. Technically, what we do is I make both of those exponents. I'm going to run a room here, right? But mathematically, what I'm doing is I'm raising them both as an exponent with a base 6. That eliminates, and then we're left with the 2x plus 1 equals 3x. All right. But just for simplicity's sake, when we go, right, that's why it's just a property. Technically, what I do here and what I did when we were doing the exponential part, right, if I have a to the x equals a to the y, again, technically what I'm doing is I'm taking a logarithm base a of both sides. Here, the log base a and the base a there cancel, and you're left with x. Here, the log base a and the a cancel, and you're left with y. All right, and that was one of our properties. They just gave you the property right away without kind of explaining it to you because it's trivial. But officially, that's how we handle that. Okay, any questions with that? All right. So the last thing we're going to talk about is what's called the natural logarithm. So remember, when we had our function e to the x, that was our natural exponential function. So just like we just kind of discovered, right, it has to have an inverse. E to the x is a 1-to-1. It follows all the same rules as our normal exponential functions. So the inverse of the natural exponent is the natural logarithm. Okay, so log base e of x. But you don't see it like that, log base e. You will see it as ln. Why it's switched, why it's not NL for natural logarithm, I don't know. But ln is the natural logarithm. That is also a common button. It's a little too blurry. On your calculators, okay? It is usually right below the common logarithm. So here you have log, and underneath it you have ln. Okay. As far as I go, I mostly refer to it as ln. All right. So when you say ln of x, I'm talking about the natural logarithm. All right. So this is just a formality. But we do have the same properties of the natural logarithm as we do for our other logarithms. The natural log of 1, ln of 1, is 0. Because either 0 equals 1. Right? Now, it may get confusing at first. So if you want to write the natural log as log base e to kind of see that relationship, you can do that. But I'm going to be sticking with the natural log. Using the inverse property, if I take the natural log of e, that's going to be 1. Okay, we use that to cancel each other out. Again, I can change that to an exponential problem, and that would be e to the first equals e. So more formally using this, if I do okay, if I perform the inverse operations, all I'm left with is my input. So if I do ln of e to the x or e to the ln of x, that's just going to leave me with x. Right, and then the last one. Right, we just have the equality property as well. Any questions there? All right. So that is the basics of logarithms. Now we're going to continue with these for a little while because we're going to learn how to do some things where the bases don't match up, right? So this isn't really part of the lesson, but if I had something like log base 5 of 4, I mean, that's a number. Okay, anytime you see logs with just numeric values being plugged in, okay, this is a number, right? I can calculate this. I'll show you how to calculate it. We don't know how to calculate it right now because if I rewrote this, 5 to what power gives me 4, well, this is going to be some crazy decimal. Okay, it's, they don't share a base at all. No factors, no common factors. So we'll get to doing this. All right, that's the next step. But for now, we know all the basics. All right, any questions?